Hello and welcome to Onshape Live 2023. It's my pleasure to present to you, along with my friend and colleague Olnish Schmiddens, the performance tips and tricks section of today's proceedings. Whilst I might be a 30-year veteran of the industry, and I know that this is always a very well-attended session, my colleague, however, is at the other end of his career and is actually an undergraduate in applied physics at the University of Washington, Seattle, and is uniquely qualified to take part in this presentation, but I will let him tell you a little bit more about that when the time comes. During the presentation today, we're going to be looking at how to get the maximum performance out of your Onshape designs, your Onshape environment, and your Onshape documents. And to do that, we're going to look at some considerations across a number of areas. One, setting up the environment for maximum performance. Two, some ground level user interaction guidance from Olnish. And then a quick discussion about performance at scale. How do we take your designs and ensure that they are performant across multiple documents, across multiple design groups, and across multiple geographies? And we're going to end up with some resources to help you. We will not be able to go in depth due to the very stringent time constraints of this presentation, but the goal is to give you insight into the areas that contribute to performance. I'm going to start by talking a little bit about the environment. As we all know, this will include considerations related to your internet connection, your hardware, and your system or browser settings. And as we all know, we do need a reliable internet connection, but there are a couple of other considerations worth going over to ensure you get maximum performance. One is whether your company uses a VPN. Most companies do. And in that case, a quick discussion with your IT group to ensure that Onshape traffic is being allowed to route to the nearest Onshape servers rather than any around the world trip. And just like you, we here at PTC use security software, in this case, Zscaler, and we take great efforts to ensure that Onshape traffic is whitelisted so that it's not constantly sniffed and can be passed through with maximum performance. Some of the other considerations to your environment surround the hardware itself and the browser. And there's a very cool built-in test or check tool that can be found at cad.onshape.com/check, which is going to do a high-level survey of a number of things, whether your graphics card is WebGL capable, whether it's currently using hardware acceleration, and what that performance is. Also, within your Onshape account settings, you will find a number of settings that will help optimize your experience, including the ability, for instance, to have your mouse replicate the button assignments of a previous CAD system, and where you might, for instance, be trying to drive multiple high-resolution monitors from a single graphics card, the ability to downscale the resolution to ensure that that performance is maintained across your sessions. Very high-level introduction to that, but there are more tools. One of the very important tools is the performance check tool that is now built into Onshape that's going to allow you to do a number of very cool things. Let me open a couple of documents here. This is a design that I did and one by a colleague of mine. So if I start with my colleague's design and look at the assembly level, we can see that the performance monitor is giving us high-level visibility into, in this case, the number of elements, assemblies, and other tabs, part studios, and so on within the document that might lead us to believe that this would be a candidate for parting out or breaking up. And at the part studio level, a very nice indicator whenever a low-performing part studio is detected, that in this case is alerting me to the fact that there is a single feature that has over a 10-second rebuild. Coming to the feature manager, the profiler allows me to sort my features by regeneration time, allowing me to very quickly identify a feature that would be contributing to poor performance. Now, this tool we're going to use repeatedly during the presentation, and you are going to use this during your own interactions with Onshape to ensure that you have maximum performance. So having set up your environment, your Onshape settings, and made you aware of that tool, I'm now going to turn the presentation over to Olnish, who will talk about some ground level tips. Olnish.
Thanks, Philip. Let's get into some tips and tricks. I'm going to start with performance and share, not in computer stuff. So this is how to work faster as a user. Now, why is it important to work fast as a user? Well, yes, some performance limitations come from the software you use, but so much more comes from how you use the software. If you were to use Onshape just like your previous CAD system, you'll see okay performance, but Onshape opens up so many windows to much better ways of using CAD that'll be much faster. So why is some college student qualified to talk about this? Well, last year, I participated in the Too Tall Toby Speed Modeling Championship, going up against about 30 users in a bracket, many professional CAD users using all sorts of CAD systems, and I did end up placing first place. Maybe I had a bit of a unfair advantage because I was the only Onshape user, but let's get into it and see how Onshape can make you work faster and how you can make Onshape work faster. First of all, I'll get into some shortcuts. I'm not going to read through all of these, I'm just going to highlight my favorite ones. I'd say the most important one is to bookmark cad.onshape.com. It's less typing, you get right into CAD, no need to search for it on Google or something like that. I'd also like to recommend using the little backtick key. It's usually the same key as tilde on your keyboard, and this lets you select other through stuff. So if you find yourself hiding and unhiding parts a bunch to select the geometry you need, try hitting the tilde key. It'll probably get you the geometry that you need. Additionally, I really love the Shift-T shortcut. This lets you, in large assemblies, drill through parts. So you can see that there's a bunch of parts in front of here, but if I just tap Shift-T while hovering over parts, it cuts away parts and I can see what's behind it. And it's really easy to dismiss just with the escape key. I'd also recommend looking at the Alt-C shortcut. This is super useful for searching. I'll get into that a little bit more later. Finally, I'd also recommend pre-selecting things before activating features. So for example, if you pre-select a plane before you start your sketch, the sketch will start right on it. Similarly, after you have finished your geometry in the sketch, you can pre-select one of the edges and then start an extrude to start it in the surface mode, or you can select a region and then start the extrude and it'll start it in solid mode. Additionally, you can pre-select for other features. For the plane, if you pre-select a point and a direction, for example, like a plane, then it will start a plane in the point normal option rather than the default. So pre-selection is a great way to save time. Next up, some navigation tips. For view navigation, the #1 recommendation I can have is if you're working in a big assembly, remember zoom to fit and zoom to window. That's the F and W key. So check out this assembly over here. I'm zoomed in all the way there. I can just tap F and I get all the way out. Now I can press W and select another area to zoom right back in. So in this way, you can navigate huge assemblies with ease, even on a touchpad on a computer. So saves you a ton of time that way. Also, I highly recommend customizing your toolbar and your S key menu. You can now add custom features to the S key menu, and you can search for features using Alt-C, which means what I highly recommend is switching your toolbar to be only the tools that you regularly use and searching for the rest. So that means that you can have a really clean toolbar optimized for your specific workloads, and you can search for things really quickly to get right back to where you need to. Additionally, you can use right-click drag. This is unfortunately only available on Mac and Linux, but it's this really cool thing where if you right-click and drag on a right-click menu, it'll immediately select the option that you want when you mouse up over it. So it's a little hard to show, but basically if you right-click on a tab, drag up, and then let go on the option that you want, it just saves you one click, but over time those clicks add up. Finally, Alt-T is a super useful shortcut. It lets you open up the tab manager on the left side. You can do actions like bulk export, search across the document, etc. A huge time saver. And Control Space lets you jump back and forth between your most recent tabs in Onshape. Next up, we have some modeling tips. So in Part Studios, one thing that I love is that you can right-click geometry and then edit the corresponding feature. So say you have 50 fillets in your feature tree and you don't know which one to edit. Just right-click one of the fillets, hit Edit Fillet, and you're editing. Additionally, you can double-click faces to view the sketch that's responsible for generating it. So here I can just double-click that face and I can immediately see the sketch, and I can double-click a dimensions to start editing. That saves a ton of time if you have a ton of sketches. Additionally, there's other useful things. So for example, if you have a measurement that you want to turn into a variable, there's now the measure to variable feature where you can hit the create variable button right as you're making a measurement. And you can also edit mate positions in assemblies. This one's really cool. If you want to position an assembly very precisely, you can actually show mates, then select the mate that you want, and the numbers that show up on screen, those are actually editable. So that means that you can position assemblies precisely based on dimensions. Finally, one other cool trick is that you can drag the manipulator in assemblies. So for example, if you want to rotate about a specific axis, you just drag the center to the axis and then you can get rotating around there. Now, a quick drawing tip is that zoom to fit and zoom to window work great there too. So if you have some sort of monster drawing with a huge amount of views, you can really quickly get around it that way. Now, I also recommend collaborating with yourself. You can right-click your browser tab and select the duplicate option in order to duplicate the tab and get multiple windows of the same Onshape document. This lets you, for example, to view the part studio and the assembly at the same time. So after you edit your sketch and accept it, you can see it update in the assembly right away. This is a great way of tweaking things and getting things to fit just right. You can also work on multiple models at once. If one of your models is a bit slow, just open up another one and work on the two in parallel. You can't break it, You won't slow down Onshape by working on two models at the same time. You can also do some time travel. What that means is you can open up multiple different windows of the document at different versions and workspaces and look at different concepts of the model at the same time. Finally, you can follow yourself. This one is fantastic if you're doing a demo, because what you can do is you can open up Onshape on the big screen, open up the same document on your phone, and then you follow from the big screen your phone, and you can freely navigate around as you walk around the stage, zoom in, zoom out, etc. And all that stuff is mirrored on the big screen. It's really slick. So here's a quick demo of editing the same feature in multiple windows. I've opened up the same window 4 times, and I've entered the freeform spline custom feature here in all of them. And what I can do is I can select points on one screen, drag the manipulators on another one, and all the time I see the isometric view update as well as the top, front, and right views. Now think about how cool this can be. You know, if you're doing a wiring thing, if you're doing industrial design, surfacing, that sort of stuff, you can view the model update from a bunch of different views at the same time. Next, let's get into some Part Studio stuff. So here's some things to avoid in Part Studios. Apply per instance feature patterns are one of the biggest killers of performance in Onshape. You'll notice that this pattern over here, it's patterning the exact same geometry, except the face pattern takes 110 milliseconds, linear pattern about 140, but the apply per instance feature pattern takes more than 6 seconds. So apply per instance can sometimes get things to regenerate right, but be really careful because it can tank performance. Additionally, think about long chains of dependencies. Onshape has no rebuild button since everything's always up to date, so be careful about making Rube Goldberg regeneration machines that take a while to get updated. Also, remember that when you're doing CAD models, generally your goal is not a CAD model, but it's a physical product. So think about what detail is actually necessary to define the manufacturing information. Maybe things like treads and plate textures and that sort of stuff aren't quite necessary. Also, now that Onshape has built-in mixed modeling, you don't need to convert STL files to boundary representation using external tools, just upload the mesh and edit. And sketch imprinting for complicated faces. Your sketches can actually take a while to regenerate too, and a way to improve this is to disable imprinting before selecting the face. It'll make it much more responsive. Now, I'm going to really quickly discuss how to build a Rube Goldberg machine in Onshape, because this is what you should try to avoid. So if you see these patterns, you can kind of know how to fix them. So what I have set up on the left here is I have one Part Studio, which is derived into another one and derived into another one, and then inserted into an assembly. So what's going to happen is I'm going to accept a feature here, and I'm going to try loading the assembly over here, and we'll see how long it takes. So I accept the feature over here, and it's taking a while to regenerate, and I'm opening up the assembly, but Onshape is not going to show the assembly out of date. So it's going to wait while this Part Studio regenerates, and then this one, before finally loading the assembly. So this is something, if you have an assembly that's taking a long time to load, look for these sorts of regeneration chains, because that's often the culprit for why it takes a long time to load. There are large improvements coming here, such as immutable caches, and this is going to improve performance here, but it's still something to be mindful of. Also, if you see a screw like this in your model, consider replacing it with standard content unless you're designing screws for your industrial profession. Now, you can also use configurations as levels of detail. A lot of CAD systems have something called levels of detail or view representations or something like that, where you can change how much detail you want to include in the model. The great thing in Onshape is that you can do the same thing with configurations. You can configure the tessellation level, so that's how much geometry is rendered on screen, and you can override that with Shift-R to view in high quality mode. You can also suppress features. So one thing I often do in heavy Part Studios is I'll have a heavy features suppression checkbox, which will just suppress all of the really big heavy features that we identified from the performance panel. Also, if you use make connectors defined in the Part Studio, you can freely suppress and unsuppress all sorts of geometry, and none of your mates will break. It also lets you use snap mode in assemblies, Shift-S, so it's kind of like standard content. So I highly recommend using make connectors defined in the Part Studio. As far as getting regeneration to run faster, monitor your regeneration timer and look at the features that are taking a long time to see if there's a better way to define them. Additionally, put variables right before the feature that uses them. If you put all your variables at the top of the feature tree, it means that every time a variable is changed, the entire tree needs to be regenerated. So if it takes 60 seconds to regenerate, and you put a variable at the top, but it's only used at the very bottom, it still takes a while. Of course, improvements are being worked on for this, but it is something to be mindful of today. So what you can do instead is you can use the variable table on the right side to edit variables, and instead position the variables close to where they are used, and that'll accelerate your regeneration. Additionally, make your Part Studio smaller. There's a great top-down design course in the Onshape Learning Center, which discusses this more, about how to use top-down sketches that are inserted into Part Studios and then used to actually model stuff. That allows Onshape to parallelize the regeneration. So one thing that's often said about CAD is that it can't be parallelized because it's single-threaded. Well, it turns out with Onshape, as long as you have Part Studios that are regenerated in parallel, it'll all go really fast. So that's something special about Onshape's architecture. Also, if there's a slow derive, switch it to a version reference, since that'll regenerate much faster. Finally, one derive feature per derive Part Studio. What this means is if you are using a Part Studio in another Part Studio, use one drive feature and drive all the geometry that you need in one go, rather than doing separate drive features, because each drive feature regenerates the entire other part studio. Now, assembly stuff. Some general assembly tips. Really, the most important thing for assemblies is to make sure that your environment is in order. What that means is going to cad.onshape.com/check and making sure there aren't any issues, and also watching out for check engine lights that Onshape's trying to show you. For example, Onshape will give you a poor connection warning if you are having network issues, and that'll help you investigate what's going on. Plus, the performance panel will have a little exclamation mark if something's going wrong there. So make sure to check out the connection and the performance panel if you're seeing those warnings come up. Also, the levels of detail thing from the Part Studio section, make sure to check that out and apply it, and break things out into sub-assemblies. Here I have a Part Studio that drives an assembly, which drives another assembly, which is in the main assembly. So I can choose what level of detail I want to work on. I can just work on this assembly over here with the connectors, or with the electronics, or the whole assembly, but it allows me to only bring in the detail that I need to get to work. For mate solve performance, the performance panel will monitor the mate solve time, kind of like what Philip demoed earlier. And one thing that can help a lot with this is making sure that you're using rigid sub-assemblies. What this means is that if a sub-assembly is fully defined, so there's no degrees of freedom inside it, it'll be rigid, which means that Onshape can use a much faster solution method for solving the assembly, which allows you to have much larger assemblies and great performance even with many thousands of parts. So what you want to do is look for the icon, and if you don't see the icon, see if there's any degrees of freedom that you can constrain down. Additionally, use the mate to skeleton strategy. So this means that you insert some sort of single skeleton part and mate a bunch of stuff to that, instead of having a bunch of complicated relationships between parts. On the topic of relationships between parts, groups are a lot faster than mates. So when possible, try using groups instead of mates. It's not just for getting your imported assemblies to stick together. It's also great for top-down design, where you have a single part studio that's driving a whole bunch of stuff in one assembly. Now, a couple of things to avoid. If you have one pair of parts, you should have 0 to 1 mates between them. You should not be using more than one planar mate between parts, and in general, you should probably avoid planar mates. So the strategy in Onshape is to use things like fixed constraints and, fastened constraints, sliders, that sort of stuff, which actually represents the degrees of freedom, rather than using a bunch of planar mates. Additionally, tangent mates, you should try to avoid them because they're expensive. They are very complicated in how they work, where they can handle very complicated geometry and complicated relationships. But the issue with that is that it's really overkill for most relationships. So try to use group. If group isn't appropriate, use regular mates. And if regular mates don't work, then use tangent mates. Now for load performance, there's a few things that you can do to make your big assemblies load faster. And now this is a non-accelerated view of an 800-part assembly loading. So you can see I start on the Onshape home screen, I click it, and then quite literally like a second later, we see the full assembly loaded in full detail. So some stuff you can do that makes this happen more efficiently is to link sub-assemblies from versions. So this means that caching can be used more effectively in order to cache geometry. Additionally, if you recently open the document before a presentation or working on it, then it'll make sure that all those Rube Goldberg machines that we discussed earlier are already set to go, and they don't need to do any additional work. Additionally, don't use a VPN or virtual desktop specifically for Onshape. It's not necessary for the security of Onshape data. It's just as secure on a VPN or virtual desktop as it is on your local machine, but it'll probably be slower. If you do use a VPN or virtual desktop, then work with your IT department to make sure that that's all set. For example, one other thing that you can do with networking stuff is if you're in China, and you can get better performance by getting a dedicated link through the Great Firewall. That can help a lot with performance over there. And finally, network security software like Zscaler, work with your IT department to make sure that it's not interfering with Onshape. Now, a couple tips for drawings before we get on to Philip's section again. So for drawings, if you upload an image such as a logo, keep it low resolution. High resolution images make it a lot slower to load drawings. Additionally, leave the view render mode on best performance when you can, and lower the variety of data in a single drawing. Where Onshape drawings struggle a bit is if you have a huge variety of data. So you have many configurations, many parts, many things all in one sheet that don't need to be related to each other. So think about, is there some way that I can logically separate, like, oh, like one thing for the pressure hold over here, one thing for the manipulator, one thing for the electronics bay, instead of trying to make one gigantic monster 300 sheet drawing, because that will perhaps struggle a little bit. Also, keep your sheet count around under 30-ish. It's not a hard limit by any means, but these are just the general guidelines. So lower variety and keep sheet count around 30 or lower. Philip, back to you for performance at scale.
I was reading the comments as you were going through this. There was so much information here and people were asking us to slow down. So just to address a couple of questions that came up, these slides will be available after the fact. And again, for the audience, the purpose of the presentation was to point you in some of the right directions. So we're going to keep going. I picked up another new one from you, which was in the layout sketches to put the mate connectors, because the validity of the assembly mates is now independent of the presence of other components. Love it, Ornis. Some great tips and tricks there from, I'm going to call you a world champion. You did win the competition and you were the only one using Onshape, so congratulations. All right, so we've taken a look at the environment. We've taken a look at some user level interactions with Onshape. Now let's talk about performance at scale. And by that, I mean the ability to keep your documents moving and performant as they become larger, as they become shared across work groups, and as they become shared across geographies. So the strategies we're going to look at, we've already covered the basics here, right? So don't model expensive features, turn off imprinting on sketches if you're trying to create sketch on very complex geometry. That was the point that, Honest, do you see my screen? Let me try that again. Share screen. There we go.
I can see your slides.
Those are your slides.
Oh. All right, well, I guess in that case, we can maybe walk through the slides on my end. All right, well, Philip will be right back. I guess while we're waiting for Philip, maybe I can start presenting some of his slides. Hopefully I don't mangle it too poorly. So the basics of modeling is that you need to be careful about expensive geometry and features. So use your performance tools to diagnose what might be kind of going wrong if you are having a slow assembly. Oh, Philip, are you back?
I am absolutely back. Thank you there. Brief hiccup. So the basics, right? We covered those. So now let's talk about some strategies for top down and bottom up, the use of versioning and revisioning, and then my personal favorite soapbox, document management. So we've covered the basics. Let's move on to design strategies. And we're going to use variable studios, layout sketches, and managed in-context designs. I love opening stuff in real time. Here is some of my data sets that I like to use. This is about an 800 part assembly, open, right, matter of seconds. Here is a colleague and friend of mine, Greg Brown's car that I'm going to be using for some of these presentations. But I'm going to start with a design, a variable studio, because a variable studio is a great way to be able to share design parameters across documents. Now, we've been used to using variables inside Part Studios, but it becomes harder to share them across documents. And one of the strategies we're going to be using is breaking up our documents. So a variable studio is a great way of doing that. In fact, in this particular case, the variable studio is being used to derive geometry for an entire violin design that Greg is working on, that will be used in a number of other upcoming presentations, including the manufacturing processes. But the important point here is there are 17 part studios, 14 assemblies, 14 other tabs, and 2 drawings. Eventually, the sheer size of a document, just like opening a whole number of files in a file-based system, will eventually start to impede the performance. We want to keep our documents to a manageable size. The obvious question to ask is, how do you know, and what is a manageable size? Relax, I'm going to show you. So we talked about variable studios. Now let's talk about a layout sketch. A layout sketch is similarly a great way of sharing information across documents. A layout sketch enables you to space allocate, or in this case, define the location of components in a plant layout. Sharing that sketch across documents is going to allow individual users in their own workspaces to create the appropriate geometry or stay within space allocation constraints. Very powerful top-down assembly design capabilities. And we are going to come back to this assembly, this document multiple times, because there are 41 assemblies here. I'm starting to get your mind thinking about your own documents. All right. So variable studios, layout sketches, and I do encourage you to use the technique that Alnis described, whereby you would attach make connectors to sketches that were going to be used in assemblies. The last top-down assembly design capability that we would encourage you to research, if you're not familiar with it, is the managed in-context design. Managed in-context design, an analog would be an assembly feature in another system, but without all the problems associated with those older methodologies, whereby, for instance, moving components to a new location would cause the assembly feature to fail. In Onshape, when you use a named view and you use an in-context design capability or a context in a part studio, you have the ability to control the propagation of change. You decide when that change is propagated, if it's propagated, and the positions of the components when that in-context feature is regenerated. Absolutely, please check it out. There are all kinds of videos available in the Learning Center and on YouTube and other places to see how to do that. Also, performance at scale. Regardless of which level of Onshape you are using, you will have one of the ability to create versions or the ability to put a component or part or assembly or drawing through a release process, or the ability to manage that through an enterprise environment. So if you are just using a lower level of Onshape and only have versioning capabilities, there are still huge performance improvements available to you. A versions the entire document, another reason to keep the size of the document manageable. It creates an immutable state. In fact, on this let slip an Easter egg that I was going to let slip, but I'm glad that he did it instead of me, that we are working on some very cool capabilities to make this faster and to preserve the validity of caches across multiple releases. And by referencing a named version, there is no regeneration check and no regeneration tax associated with using that version. Absolutely. Please, 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 in your drawings, in your assemblies, consider using versions of parts in documents, or even better, a revision. Why is a revision better? It is object specific. It is a part, it's an assembly, it's a drawing, it's a table, whatever. And it has the ability to go through a release process. This brings me to my personal soapbox, and actually the last big topic that we're going to be talking about today before the Q&A session, which is document management. I posed the question earlier, how do I know when it's time to break up a document? Well, now I'm going to tell you. An Onshape document is an arbitrary container. It can contain any amount of parts, assemblies, or drawings. One of the great advantages of having everything together in the same document is the real-time associativity between an update to a part in a part studio and the update or change as reflected in an assembly or a drawing. There comes a point, though, especially in a truly professional product design environment, where you want to start controlling change, you want to revision manage, or you're now putting those parts or assemblies or drawings into a PLM system or PDM system to start the procurement process, the supply chain management, and so on. So you're going to want to add some rigor to this. This is the point in time where I'm going to tell you that it's time to start breaking up the document. Remember this card that had 41 assemblies, 12 other tabs, and 10 part studios? Well, I have a specific component here that perhaps it's time to release manage. I'm going to, here's the component. Here is the component, and there is a drawing associated with it. And I want to actually release this, this component. Can I do it from here in this document? Absolutely. I could go ahead and create a release candidate, but maybe it's time now to move this part out of the document. I want to demonstrate this to you so you can see how easy it is. I want to move to a new document. I'm going to move the spur gear holder and its children. Notice that, here we go. Sorry, I'm going to move this. Why didn't it? Sorry. I want to move the document, which will take its parent, the component, and I will move it to a new document with its child, moving all reference tabs, and it's now gone. Does that mean the assembly breaks? Does that mean that something bad has happened? No, this is a very normal part of product development. I'm now adding rigor, I'm adding a release process, I'm moving that part and its associated drawing out of the main document. To cut a long story short, a document will start as a single document with the entire product design in it, and over its lifetime, we'll have components, subassemblies, and parts split out into separate documents, each of which start with the fastest state possible and giving all team members the fastest performance possible. So the document has been moved out. Let's open up the new document. Here's the Spurgear document that was just created. Now, is this a one-way street? Does this mean that I can never go back to the assembly and have changes propagate in real time? Absolutely not. I can move this back at any time. So returning to the assembly here, there would be a reference to a version that was created on the fly as I parted out this component, but I can return this component to that document at any time. Back here in the main assembly, we will see that this component is back here in this subassembly in the drivetrain assembly. So what was originally linked as a version is now linked, or revision is now back in this document. And after the connection, after the update, I can then move it back out to the other document. I'm gathering that we might be experiencing some technical difficulties. Why don't we move on to the Q&A portion of the presentation? Honest, if you could bring up that slide. The timing is actually pretty good because that was my last topic. So we ran through this very quickly. It's a very short presentation. There are a number of resources. Honest, could you go back one slide, please? Yes,
absolutely.
A number of resources. So the performance comes from the environmental settings. If the performance, there are a number of tools available within Onshape to help you diagnose the problem. Is Onshape trying to alert you to a problem? Can you isolate the problem by moving it to another document? And if you can't identify the challenge you're facing, please contact tech support. They're very adroit and able to help you. What resources are available to learn more about some of the topics that we've talked about here? There is, of course, the Onshape Learning Center. There are recorded webinars, and there is, of course, the user-supported Onshape forum. All right. Thank you for attending this brief presentation. We will open this. Of course, please register for LiveWorks 2023. And we will take some questions, and there is quite a backlog of them here. Thank you very much. Olness, you were asked a couple of times whether you chose to use a 3D motion controller when you're using Onshape. Do you have any thoughts on that?
I've actually never used a space mouse, so maybe if I used one, it would go even better. But for me, at least, I found that just like the Mac touchpad is quite good. If I do need to go extra fast, I do also have a mouse. I've mapped some of the keys on the side of this Logitech mouse to go to some shortcuts in Onshape. But I just basically use the touchpad 90% of the time, and then if there's a speed modeling competition, I'll use a mouse.
Fantastic. There are some questions about if there's a threshold in the performance level of Part Studios. And no, there isn't really a number. I would just keep track of the total regeneration time. And if you find, and I do this myself with complex designs, if you find that there are multiple areas of optimization going on in your Part Studio, it might be time to break up that Part Studio. It's actually possible to take develop a Part Studio to a particular point, version it, and then derive that Part Studio into another Part Studio. Again, the important thing there is a version or revision to prevent the rebuilds further upstream. A Part Studio shouldn't be optimizing 9 different aspects of your design simultaneously. So there isn't a set number, just watch the total regeneration time. Let's see.
Although I will say, I think the number that you do need to think about, like, okay, is this the right approach? Is closer to around 1,000 features is generally where you start running into potentially some issues. Of course, it depends on the complexity of the features, etc. But that's the number where I really think hard about, is this the best way to approach this design?
Fantastic. There was a question here about, is it when you were collaborating with yourself, Allness, does it slow the design down if you are collaborating with yourself or if multiple people are collaborating? Maybe you'd like to take that one.
I haven't noticed it, honestly. Yeah, it's if you're working on the same design at the same time, the thing is the regeneration happens server side and then it's sent out to everyone. So what that means is, it's about the same, at least in my experience, whether you have 10 windows of Onshape or one window of Onshape.
Fantastic. And there were questions. So there's a really good philosophical question here about balancing the speed of modeling and creating an assembly robustly. So it's a great question and is more of a philosophical answer. You have to have strategies in order to keep the assemblies moving. Maybe I could try sharing my screen again. It sort of died earlier, but there's a lot of very, very cool things that we can show here, and we still have 8 minutes. So
one other thing I would recommend on the balancing the speed of your modeling versus the quality of the model is consider doing a first draft, which is really scrappy and poor practices all over the place, just to get your ideas out, and then do a second version where you try to apply better practices. I found that rather than trying to get everything right the first time, it's often a lot faster to do a really quick low quality model, and you have a very clear picture of what you want to build, and you can quickly build it the second time with best practices since you know exactly where you're going.
Oh, yes, especially if it's a new type of design that you are working on. Getting lazy and abandoning the practices is something that is usually where it comes off the rail. And I have to force myself to stop and use the better practices to make sure that that doesn't happen. As a quick example of how robust Onshape is, this is a project I've been working on since 2017, and I've tried multiple branches. I've had multiple release candidates. I've changed the design methodology multiple times, but my strategy for creating assemblies and my strategy for modeling is quite consistent. And I always try and stop myself if things are getting horribly complex. We used to say to people, if something's difficult in Onshape, you're probably doing it wrong. And that's a good question to be asking yourself. If it's taking a long time, if it's difficult, if it's complex, just see if someone else has solved the problem in an easier against our hard stop at this point, Allness. Are there any closing comments that you would like to offer up to our audience?
I don't think I have any particular closing comments. Maybe we can grab a couple last questions.
Okay.
One question was, is there anything we need to adjust in our browser settings to get best performance from our graphics card? So it's going to depend on what operating system you are using for how to get your browser to use your graphics card. If you're on Windows, it might be in the NVIDIA control panel if you have an NVIDIA card or the equivalent for AMD. In Windows 11, I believe it's something that's in system settings. On Mac OS, generally, it's related to whether you have power saver mode enabled or not. And on Linux, that'll depend on your distribution. But make sure that you have your dedicated graphics card assigned to your browser. That will help a lot with performance. And then the other thing is if you're seeing weird graphics artifacts or like a black background or really low frame rates or things like that, it's possible that you're running into Chrome has a certain like list of graphics cards that will not enable full graphics on, and it'll instead do emulation on. There's some Chrome flags that you need to set for that. I would recommend searching on the Onshape forum if someone has had a similar issue, and that will help you get everything configured correctly. So the most important thing, though, is make sure your dedicated graphics card is being used for Onshape.
Fantastic. Well, we are up against our hard stop now. I want to thank you, the audience. Again, very high-level introduction. Check out the Learning Center, check out the web pages, and check out the forums. So thank you very much, and here's to keeping your Onshape components and assemblies and drawings moving smoothly. Thank you.